Hello, I'm Tom Hollingsworth, and you are watching Networking Field Day 13. We are here in San Jose, California with Viptela. We have invited a group of networking bloggers, speakers, podcasters, and luminaries of the community to take part in this discussion, offer their opinions, ask questions, and add their voice to the conversation about software-defined wide area networking. If you would like to learn more about Tech Field Day, including how to become a presenter or a delegate, please join us at our website, techfieldday.com. If you would like to see more videos about this and other exciting technologies, please check out our YouTube channel at youtube.com/techfieldday.
All right, so let's look further, right? So I'm trying to bring up a new site. So the device had been provisioned, right? So one thing to understand is that I do want to bring just one point in here, is that when we do zero-touch provisioning service, every device, Ramesh mentioned about trust or zero trust, every device comes with pre-built or preloaded certificate, signed certificate. It gives us a unique identifier for that device. Every device that ships out of the manufacturing floor, right? The certificate is pre-built inside. When a device comes up, it goes through a bi-directional certificate-based authentication between itself and a management system, between itself and controllers. Everything is predicated on a bi-directional trust between the systems, right? So we assume that this process is done, right? The device has been brought up because it's really zero touch. Like there was no point for you to see that, because what will happen is that you will just stare at this and all of a sudden the device will come up, right? So there's zero value to show you that. Now the question is, what happens after this device come up? Right? What if it was shipped to your wrong location? What if it ended up with your competition or your neighbor? What do you do? So as part of the process of setting up the device, you can decide on a trust level for the device. And you can say it's an invalid device, which means from the remote side perspective, it was zero touch. There is nothing I need to do. I don't need to click anything. I don't need to browse anywhere. It's a completely zero touch, yet I have no connectivity. It's an action that an administrator have to take to go into the management system and enable that device, right? There is also staging, where I can work on the device, stage it, which means it will get some connectivity from control plane, but no data plane. What our customers are using this for is they stage the devices before moving this into production. So I can have full connectivity into the device. I can do whatever I want configuration and policy-wise on the device. When I'm ready to flip the switch, then I can promote this into the valid mode. That will open up the data connections, and the device becomes fully operational, and now not only the control connections are up, but also data plane connections, which are the IPsec tunnels, are also up, right?
So
yes?
So if vManage is running in your server environment, is it like a cloud brokered connection for the vEdge to find
yes.
your management platform?
Yes, there is a ZTP service that we offer as a service. If you want it, you can also host this internally. For some of the larger customers that want to have a ZTP, internal ZTP service, they can do that. So it is sort of like a broker, kind of, that basically maps your vEdge into your organization. It is very lightweight. It's sort of stateless in the sense that it has no customer data. It just calls home, hello, I'm customer A, go talk to your customer, to your infrastructure, disconnects.
Right.
Okay. All right, so the reason that I didn't find it is I was looking at the wrong screen. So here's the device. You can see that it's been sort of ZTP'd, and it shows invalid, right? Which means it's not operational, it's standby device, so to speak, right? So what I'm going to do now, if I look at the geography map in here, this is a map that shows all the devices. That device has actually been pre-configured with GPS coordinates, so it will appear somewhere in New York area, right? So let me go back into this. So where we are now is a device had been shipped. It's at the customer, and I've decided that I don't want to activate them immediately. I want to go through the process of validation first. So I'm going to put this into a staging mode first. So once I flipped it into a staging mode, I basically have to send it to the controllers. What it does is that vManage, as I mentioned, it's a separate system. There's a vManage system, which is a management system, and there's the controllers. So for the device to be able to establish the control plane connections, the management system, I made the change. So I made the change in the vManage database, right? But the controllers need to now know about this. That's what I did. I pushed it, and now controllers are aware that the device is allowed to connect. So you see it's been pushed. So now if I go to network, I can see this device appeared. It shows in the staging mode. So if I go inside, I can basically, I can see the information about this device. I can see what are the interfaces on it. I can see things about it. But if I go here and I say, show me what IPsec connections you are building. Nothing. I'm not building any IPsec connections because there is no data plane yet. It is completely device that is being staged now, ready to be activated. Now, the next step that I can do, and I can promote it into the fully valid device. So this is, of course, requires a maintenance window for you to do that, because that activates the tunnels, so to speak, right? So all the devices now need to start building tunnels. So the device does go through a process where it loses some of the connectivity. So it's a maintenance window of activating the device after it's been staged, right? So I'm basically repeating the same thing. I'm pushing this to the controllers. Now the device has received sort of instruction to be activated. So we need to wait a little bit for a few seconds for the device to for the network to come up. Now, in the meantime, I can go to the map and I can see this device isn't here already. Actually, it was here even when I was doing staging. It was there. I didn't show you on the map, but it was there. It was there as well, but it had no data connections. So it says unreachable. It's going to clear in about maybe 10 seconds or so. And what I expect to see is I expect actually IPsec connections to come up. And when the IPsec connections come up, then it actually can communicate to the rest of the devices. And I'm also going to show you how all of the reachability information that is now received through the controllers about all the other devices that it can communicate with. So let's see. OK, I think it's up. All right. So now if I go into here and I can say, what are the IPsec connections that you are building? All right, it builds IPsec connections out, right? Now, what are you learning through those IPsec connections? What is it that you know about the network now? So I can go in here and say, show me your routing table. It knows about stuff. You can see here some of them are marked as OMP. OMP is our control plane protocol. It's called an overlay management protocol. Think about that as an extensible control plane protocol that communicates between all of the devices, all of the vEdges, and the vSmart controllers, and it passes information around. It is extremely extensible. It is extremely scalable. What it allows it to do, it allows it to move massive amount of information from the sites to the other sites through the controllers. So imagine site wants to advertise its own prefixes. This is what I know. It's going to send it to the controllers. Controllers are going to send it to the other sites. Kind of like a reflection mechanism. Now, is it just reflecting? Absolutely not. There's a whole lot of policies that I can do on that reflection. I can send the information, yet I can say the controllers can influence the information that gets reflected. I can change next hops. I can say, don't advertise that route anywhere else. So it's not just reflection. It is reflection with a whole lot of control. So when we say policies, there's lots of dimensions to policies that we have. Some of our policies are acting on the devices themselves. Some of our policies are acting on the controllers. That gives us lots of flexibility on what happens with that information when it gets distributed. Just because a device learned about something and sent it to the controller to be reflected, it doesn't mean it's just going to go through the controller untouched. Controller may actually introduce quite a lot of things to that update.
Because I could have a full mesh topology here. Yes. I think that's what was on the screen.
Yes.
But it could be hub and spoke, depending on the policies that I've built.
One use case that you can think about, that's Ethan's really good point. One thing you can think about is that I have two sites. I'm going to advertise reachability to them, right? So if they're going to learn about directly connected subnets, they're going to try to communicate directly between them, because they say, I have a tunnel. I just learned about that other subnet. I can talk to it. However, as it passes through the controller can actually set a different next hop for that prefix that it gets advertised. That's going to force the traffic, even though they have a direct connection, it's going to force the traffic to go to, maybe I can set a next hop to the data center. And I can do this on a per VPN basis. So you're right, I can use the manipulations done on the vSmart controllers on those updates I can use that to construct a hub and spoke topology. For anybody who built networks, that should make a whole lot of sense.
Now, you're talking about a lot of detail about setting next hops and these kind of
Yes.
things, and I'm thinking about BGP policies and that sort of stuff.
Yes.
Now, if I'm writing a policy, is it a high-level abstraction of all that, or am I actually getting down into the guts and keying in IP addresses and that sort of thing?
So the policy is, the way that we approach a policy, it's a policy language. The reason that we have a policy language is that because the flexibility that you get in a system to determine how the traffic is going to follow requires you to have a level of expertise to build this policy because there's so much flexibility into it. So what we have a policy language that describes your intent. And I'm going to show you at some point.
Yeah, so simple hub and spoke topology can be, these are my hubs, these are my spokes, and the network will figure out how to manipulate around it.
I'm going to keep an eye on the time.
Policy language sounds suspiciously like command line interface. but I don't think it is that exactly.
It's a policy language. It depends what you call command line interface. It's a policy that is enacted it's defined centrally on the vManage, and it's acted upon by either the vEdges or the vSmarts, depends on how the policy is built and where it says in the policy. Right now, the policy is a policy language.
That's
I don't
the
want to call it.
configuration on the controller,
Yes.
which is then interpreted and pushed out to the edges.
In fact, it's a configuration on the management system that pushes it to either the controllers or the vEdge devices themselves based on the intelligence the system has about where that policy should go. Some policies go to the controllers, for example, to build those hub and spoke topologies instead of doing full mesh topologies. Some of the policy goes straight into the vEdge if I want to do some manipulation on the vEdge itself that does not concern the controller. For example, maybe set the next hop straight on the vEdge to determine take MPLS or take broadband. So there's some decisions that are taken on the controller. There's some decisions that are taken on the vEdge. There's lots of flexibility that is built into the policy. I'll go as far as making a bold statement. There is pretty much nothing that you cannot do with the policy. Any crazy traffic patterns that you can envision, you can. Is it sophisticated? There is a small learning curve. Yes. We guide the customers through the journey of what it means to construct the policies. Once you build the policy, of course, you can reuse it. As customers deploy our solution, they get more comfortable with the policy, they get to implement it. The policies, not everything is complicated. Some policies are very simple to build. Other policies are sophisticated and require really understanding of what you're building. But the flexibility is ultimate.
And also these policies are now network-based policies rather than device-level policies.
Yes.
So when you define these policies, I'll give you an example. Say you have a policy where you're saying that in my network I want my real-time traffic or voice traffic or something to prefer MPLS. So now, and I'm coming back to your IP, like the next hops thing. So now you don't have to go and define it per device and saying that, oh, from this device, if there's voice traffic, this is my next hop, because every device, every vEdge, it's going to be a different next hop. So you define a network level policy where you just say that, oh, I want this traffic to take MPLS. So now the network, all these devices in the network, they're aware of the transports they are connected to, they're aware of all the services they are connected to. And also going back to what David was saying, if you have a firewall and you want certain type of traffic based on some policy to go through a firewall, all you need to do is say, I need this traffic matching this criteria, go through a firewall. You don't need to know the IP address of the firewall. You don't need to know the IP address of the next hop you're going to take to get to the firewall. So the network is aware of all the services as well as the transports it's connected to.
Yes.
So we have abstracted all this low-level information from the policies. And the policies now become network-level policies rather than device-level policies.
Yes. So just to complete the thought, just because it's a policy language, don't think about that as, oh my God, this is now device-by-device configuration now. It is completely abstracted. It's completely transport independent. It allows you to express your intent. But however, because enterprise customers have so much intent, and they're trying to build so many things, that doing the policy in such a way gives you that utmost flexibility. Yeah, sorry, you had a question.
Sure. So that sounds great.
Yes.
From an operations standpoint.
Yes.
So ideally, we're pushing this out to many remote sites.
Yep.
That's one of the compelling reasons to use this type of a technology.
Yes.
I have experience with one particular vendor And every time we want a new policy or a new feature, a new function, even if it's just security vulnerability remediation, that gets updated centrally somewhere, and then we can't push that out until everything's on the same version. So again, that sounds great, but in an operations standpoint, is that required to do here, where I have a literal global outage while we're always updating something? I guess it speaks to the maturity of the product. And
yeah. So the policy has a policy scope. If you define a policy, you can define a policy scope as being enacted on the entire network, on a subset of the network, or in just individual site. Right? So when you make it, a policy changes, because it's really not vulnerability the way kind of you described this is, if I stay on a policy side of things, right? It's really the scope of the policy that is going to decide of how wide that policy is attached, right? So you should know what you're doing when you're operating the product.
Yeah, and to add, the management plane, the control plane, and the data plane can all be on different versions. We can go really far, really forward. They can be on completely different ones, and you'll still be able to make it work.
And that's sort of what I was asking.
Oh, yeah, then I apologize. Yeah, from that standpoint, absolutely, yes. There is no need for you to be on the same version. There's no requirement of anything like that, yes. All right, I'll move on. So we see the device came up, it learned a bunch of routes. So now what I'm going to do now is, one more thing that I wanted to show is in here, if I do, so if I look at the interfaces, there is one interface that was brought down in here. You see that it actually shows in a down state, right? So this is how I take my, basically, I take site that is now an MPLS site that was brought up, because this is actually an MPLS connection. I want to add another connection to it, right? So a broadband was delivered. I just want to unshut the interface and let it go. So if I look at what exists right now, if I go again in here and I would say, for example, show me BFD information, it's going to tell me that all of the connections are going through something which is called an MPLS, right? Now, if I want to enable an additional transport and turn the site into a hybrid site, all I need to do is I basically need to unshut the interface and see that it establishes the connections to the other sort of underlying network, right? So I can do that through everything is templatized, right? So if I go into the templates, I have, of course, it's a very small system, so there's not many templates in here. But if I go into here and I can see this template, what devices it's attached to, I know it's attached to site 2, so I can go inside and I can actually look inside the template. There's different interfaces that exist. I know that on the transport side in here, transport side for us is basically the WAN side, right? I can see one interface that is provisioned, which is this guy. So what I can do is I can basically say I want to add another interface. I can select an interface that I want to add, and I can say update. And what it's doing, it's basically just generating an update to the VH router and adding another interface that VH router now knows about, right? So the moment it's going to finish, which should be momentarily, it's pushing that update. So we're going to see that additional connections would come up on that device, and those connections would be over broadband. So adding a transport into the VH router is as easy as just plugging a cable into it and making sure the interface goes up. The device goes through like an immediate discovery process that says, oh, what can I do with that new interface? Who can I reach over that interface? And it's going to try to establish a communication over that interface to all the other VH routers that are connected over that interface somewhere. So if I enable broadband, anybody who is on the broadband on the other side, if I don't restrict anything, is just going to try and connect to them. So if I go back to the network and I choose this device, and I go into the real time and I say, oops. I now learn whole other type of connectivity that I can get to. So the point that I was trying to make is that as you are migrating from sort of one type of connectivity and adding an additional transport. It's as easy as just enabling an interface on the device and letting the device, because the device has all the intelligence about, through the control plane protocol, it has the intelligence about all the other devices that exist in that domain. So when it comes up, when the interface is added, it's going to start basically sort of crawl, so to speak, through that new transport, try to find the destinations that it can get to through that. Because it tries to give you the utmost connectivity, if it's unrestricted, right? Of course, you can do a lot of sort of manipulation to say that do or don't, but if you're not restricting that, then it's just going to try, sort of like a web search engine would crawl the sites and try to get you the content. So we crawl the connectivity types and try to get you to all the remote destinations that exist. So you're able to establish as many connectivity options from site to site to start leveraging one transport and then another transport. All right, so let's let me go into the into enabling a connectivity into the legacy site, right? So when you're thinking about how you connect to the traditional environment, so you have your hybrid network, right? So you built your hybrid network. It doesn't matter how many sites it has, but the principle is the same. You have some sites, you have remote sites, you have some data centers, you may have some cloud locations in it. Doesn't matter. At the end of the day, it's a hybrid network, right? So now you're trying to connect into a traditional world. So what is in a traditional world? It's either the site that have not yet migrated, or it's some services that are provided by the service provider in the underlay space. Many of the service providers provide multitude of services on the MPLS network, be that security services, voice services, or whatnot. How do I connect to them? Because they are, for me, it's sort of an underlay service. I live in an overlay. I send traffic from one side to another over the tunnels. Now I need to go into a service that is not reachable over the tunnel. It goes over the underlay. So what do? I have two options. I can either send this traffic to the data center and let it go out to the data center, and that's where I can have a more meaningful peering relationship with my service provider, BGP or whatnot, to learn the routes that are available on the MPLS network from the data center. Now there's another option, and that's what I'm going to show you, is to be able to establish that BGP connection or that BGP peering relationship directly from the remote site over the same interface that carries my overlay traffic, over the same interface establish the connection to my MPLS service provider. So I'm going to learn routes from the overlay, and I'm going to also learn routes from the underlay, and all of that over the single interface, because I'm able to establish a BGP connection with the underlay world as well. So what we have is very simple, one site which is non-SD-WAN site, one site which is an SD-WAN site. Enable BGP process on here. Actually, the process is enabled, it's just the neighbor is unshut. And what it's going to do is going to now, once I enable BGP, it's going to learn routes through BGP, and it's going to allow me to interoperate between the overlay sites and the underlay sites, because now that VH device has a visibility into both.
So during the migration, all you have to do is enable BGP on the new site that you have brought up. Your existing sites that are on your traditional network do not need to be touched.
And do you select sort of a specific gateway that will be that bridge between the overlay and the underlay, or does that happen at multiple points?
Yeah, so that's the option number one that he was talking about, where you have a gateway. Option number two is there's no gateway. It's actually a site that connects to all the other SD-WAN sites over the overlay. It talks to other non-SD-WAN sites directly through the underlay.
Yes. So you have a choice.
So you can do that on a site,
yes,
on a site-by-site
yes.
basis.
You can do this on a site-by-site basis, and every site that wants to get the shortest path reachability into the underlay services can do that. So it depends on the flavor. Some customers prefer to actually send it to the centralized location like data center and let it exit to MPLS in the data center because they feel it's more controlled. But some others that want to kind of minimize the backhaul that goes into the data center, they want to send it directly onto the underlay at every site. And again, I'll stress it out again, it's over the same interface. So it's not like a back-end LAN connection that goes back into your MPLS network. It's the same interface. Because
that's important because very often if you've engineered your WAN with certain bandwidth, right, and then you go to make a migration like that, you may not have been prepared for the amount of aggregation bandwidth you're now going to take if you're bridging everything at the data center, because that's not how the MPLS worked in the first place. So
couldn't have said it better. Absolutely.
Yes. Yeah. Another interesting point is that when you deploy MPLS service, we do not require you to keep an MPLS CE router in place. Because we are a fully featured router in this sense, and we support routing protocol on both LAN and WAN side interfaces. When you go and you say, I want to transition this site from being sort of an MPLS only to a site which is which is a hybrid site, right? I can take the connection from the MPLS service provider, and I can plug it directly into the vEdge. There is no need. So the CE is gone.
You don't have serial interfaces, though, do you?
We don't have serial interfaces.
Okay, just checking.
Almost gone.
Do you have
Almost
gone.
gone.
Do you do IPv6 support? All this is IPv4.
Yes. IPv6 and IPv4.
And do you support partial mesh topology? So if you had a group of like point-to-point links between certain sites, can that be integrated?
Absolutely.
Be more clear on the IPv6 support. Is that for management only, transport, or both?
Both.
Overlay and underlay?
Yes.
Okay.
So the point that you were making, I didn't finish my thought, is that when the MPLS CE is gone, all I have at that site, because we are trying to make a deployment very slim deployment, right? We don't want to, because what's the point if I need to keep legacy routers in place, right? So this device gives you an option to connect all the transports that you want, MPLS, broadband, or built-in 4GLT, straight into the device without reliance on any other devices being present on that site. So an option for you to go LAN side interface, it's not even an option. The CE is gone. I don't have a backend connection anymore. So this is a very sort of powerful tool that our customers have adopted, is that it really creates that cost savings that people are really after. Is that what's the point for me, because I'm in a hybrid mode for maybe years. So what's the point for me to keep on the MPLS CE router in place? So what I'll do here is that I will go.
Reminder, we are at the 1 hour mark. So
Yes, go a little bit faster. So I'll go to the legacy site. This is the Cisco CSR. So it has a BGP connection, and let me just make it a little bit. This thing cooperates. Anyways, I can do show IP route BGP, and see that I'm learning a bunch of routes. This is my relationship with the service provider. This is a traditional site. Have not migrated to MPLS. Sorry, to SD-WAN. It's a traditional MPLS site, right? Okay. So what I'm looking for is that the two sites that want to communicate is, if I look at what's on the legacy site, and I look at what's defined under the BGP, I'm seeing that my local network is 192.168.3.0. This is the network that exists on the MPLS side, that legacy site. You see it's being advertised into MPLS, into the service provider. But of course, I'm not picking it up on the other side because I haven't established that relationship yet. So if I go here and I go back into for example, the device that I'm trying to communicate, which is a Site 1 device, and I say, show me your routing table. And I say, what I'm looking for is 192.168.3.0, because that's the legacy site. It's not here, because I haven't enabled BGP yet, so I'm not learning about it yet. So what I'm going to do is I'm going to go into the template again. I'll speed it up a little bit, so I'll just search for it. I'm going to go into the template that is applied to an SD-WAN site. I'm going to edit this template. I'm going to go into the neighbor statement, and there's a neighbor that has been created in here. I will expand it, and I will say I want to unshut that sort of neighbor. So now an SD-WAN site is going to establish a BGP connection with an underlay. So it's already learning a bunch of stuff over the overlay. So it knows how effectively communicate with the rest of the overlay in active-active over any transport. What it's trying to get to, it's trying to get to a site which is purely an MPLS site, has no SD-WAN on it. So now that I've enabled the BGP process, it's going to kick in, and we need to push the template. And when the template is pushed, that's going to establish the BGP connection from an SD-WAN site through the underlay into the service provider. And that is going to allow me to learn about the remote legacy site that have not yet migrated allowed it to be learned by the SD-WAN environment. Okay, it's done. So I'll go back to where I was before. I'll choose Site 1, and I'll just repeat the information about, actually I can just say BGP routes. Here's the guy, 192.168.3.0. This is the guy that I've now learned from my service provider. And if I go back to here, and I'll just repeat this command, here's the guy. I learned about site 1. So what I've done here is basically I've taken a site which was an MPLS only site, my traditional site. I haven't done anything to it, but I need to get connectivity to it. So what do? I already embarked on an SD-WAN. I'm deploying sites, but I cannot live in SD-WAN world only, right? I need backward compatibility. I need backward connectivity. This is one of the ways of doing that. Establish BGP with your service provider, learn about the underlay routes. Now I know how to get from the overlay into the underlay, reach those legacy sites.
But can you filter which prefixes you do that for?
Absolutely.
Okay, because otherwise you'd be in a case where you might be advertising all overlay prefixes as equal cost into the underlay BGP, and now you end up with really suboptimal routing to get.
Yes. There's lots of controls that you can have over this BGP relationship because it's a full mature BGP implementation.
And even
LAN side and WAN side. Yeah, shocking. It is shocking.
And even if that happens, there is enough juice that we have built to arbitrate across. If I learn something through OSPF, BGP, underlay, overlay, we go through a comprehensive best path to figure out this is the most optimal route and use that. So built on top of very sound routing principles.
Okay.
So, sorry, David, go ahead.
And then because of your policy language, once the traffic enters the edge, you no longer actually have to make a routing decision, right? You can make a policy decision of how to pour the traffic.
It depends where it's going.
Right.
If it's going to the legacy site, it is a traditional routing decision made by that VH device to go underlay, no tunnels involved, no IPsec, no SD-WAN control plane, just go straight into the service provider, underlay, and then reaches the destination. Return traffic will go from the underlay, reach that site. If I'm going overlay, I have my OMP protocol that advertises all the reachability to other sites. I'll go on the overlay. So I effectively keep on bringing my sites, sort of as I'm moving them into the SD-WAN, they never lose the connectivity to my traditional MPLS world.